Hello everyone, I am pleased to introduce our company's self-developed high-frequency electrosurgical unit analyzer. This device complies with SIG-FON 2172009 high-frequency electrosurgical calibration specification. The main functions of this analyzer include high-frequency electrosurgical unit output power measurement, output power curve measurement, high-frequency electrosurgical unit leakage current measurement, and RAM testing. Let me first introduce the appearance of the instrument. The front panel includes a power button, a USB interface, and 4 test ports. The active surgical electrode interface, the earth ground port, and the RAM test ports CMQ1 and CMQ2. The test operation area features a 10-inch color touchscreen. All test parameter settings are selected and configured through this touchscreen. Now, let's use a Becky-generated radiofrequency thermocoagulator as a sample to perform a test. First, set the instrument's test item to test power. On the operating interface of the sample under test, set the output power to 5W. On the instrument side, set the test mode to continuous mode. Set the test polarity to monopolar. Set the test load to 100 ohms. Set the trigger mode to external trigger. Click Start Test and the instrument will monitor the signal under test in real time. Then, manually trigger the output power on the electrosurgical unit. On the instrument, you can see the output signal waveform and result data. The left chart displays the waveform of the signal under test. The lower right box shows the result data of the signal under test. The displayed parameters include current, power, voltage RMS value, voltage PK value, voltage peak-to-peak value, voltage maximum value, frequency, and crest factor. Click Pause during the test. The test signal waveform curve and result data will pause updating. You can zoom in on the waveform curve to observe the waveform of the signal under test. Then click Start to continue the test. The test signal waveform curve and result data will continue to refresh. Click Stop to end the test. Now, let's start testing another mode, the pulse mode. Switch the sample under test to pulse output mode. Set the output power to 40 years W. Set the pulse width to 3 ms. Click Start to output power. On the instrument, select Pulse mode. There are 2 charts here. The upper chart displays the waveform curve of the signal under test, which is a pulse signal. The lower chart shows the pulse cycle time and the pulse width time of a single pulse. The lower right box shows the result data of the pulse signal under test. The displayed test data include load voltage, load current, load power, load PK voltage value, frequency, pulse width time, pulse cycle, duty cycle, cycle voltage, cycle current, cycle power, and other parameters. Click Pause Test. The test signal waveform curve and result data will pause updating. You can zoom in on the original signal graph to observe the shape of the waveform peaks and valleys. Click Start to continue the test. The test signal waveform curve and result data will continue to refresh. Stop the test. Testing is complete. Thank you, everyone.